We talked about the new 14-bit macros, which are instrumental in creating your initial overlays. But there's a lot more available to the programmer than just 14-bit overlays to create your applications. We'll summarize all of these operations that you can program in this video. As a summary first, we have the 7-bit CCs on channel 1 absolute or channel 2 relative that we've used all along. These can be used just like you use them from an external controller. Send the CC and send the value. We have a set of CCs on channel 16 that are more control CCs. These also are instrumental for creating our poke interface that we'll talk about. Then there's the 14-bit CCs we've already discussed in the previous video. We have the idea of pokes that we have to discuss. This is how you send information to change things in the matrix. For example, change an oscillator filter type or change a shape generator shape. You can use pokes to change all your convolution values. You can also use pokes to change graphs, bit banks, kinetic banks, a lot of different things. And then we'll end by talking about EaganMatrix Streams that are used when you need to change more than just a couple data items. Here's the table of the 7-bit CCs we've been using all along. These, you just send your CC and your value, and you don't really have to worry about much else other than if you have a control surface or controller, you may want that to be in absolute mode or relative mode. Remember, relative mode for our EaganMatrix means it's the CC65 goes up and CC63 goes down kind of relative mode. There's actually 4 different Midi relative modes. You won't have to worry about that so much. That's handled internally for you. But if you have an external controller, you may have to pick which one of those relative modes to use. Then we have channel 16 CCs. A lot of these are used just for editor operation. And remember, almost anything you can do with the editor now, you can do in an overlay. But a lot of stuff you'll do in the editor, like actually programming in the matrix, changing formulas, that typically you won't do in your overlay because that's going to require a lot of programming. Even though you could recreate the editor if you wanted to. But mostly overlays are going to be used to put a user interface on a preset that's already been programmed. Some of the more important channel 16 CCs are CC34, that's going to be used to select a formula in our formula poke. We'll talk about that. CC51 is used to set tuning grid. CC56 is going to be used to set our poke types and stream types. You can use CC71 to 73 to get polyphony information. There's a whole set of requests that can be sent using CC109. For example, you want to request the EaganMatrix to send you the names of all the presets. So here we have to talk about reading large sets of EaganMatrix data. We'll save that mostly for another video. Then you can do stuff like read CC102, 103 to get the current firmware version, etc. One thing to note, there is a random loop check CC that's sent out every second or so. This was CC117 in the previous release. In this new release coming up, that's going to be sent on CC82. You may want to look at that because that's what in some cases is causing for the Osmos, the Haken local mode to turn itself off. So in some cases, you may have to go into your DAW and remove CC82 now instead of CC117 if you're seeing that operation. Our 14-bit macros we've already talked about. There's the unipolar macros that are used on CC12 to 17 using the same macro numbers we've been used to. Then there's the bipolar macros that use LSB CC86 for half of them, CC97 for the other half, and then a MSB CC value that goes with that to give you your bipolar 14-bit CCs we already talked about. Then we have our matrix pokes. So this is a new operation that will allow you to change things, generic operations in the matrix that are not specific to a formula, like for example, changing the split mode. To perform the matrix poke, you send a CC56 on channel 16 with a value of 20. That signals matrix poke data is going to follow. Then you'll use a poly aftertouch message on channel 16 again that takes two values. It's not going to actually be the poly aftertouch data you're used to. The poly aftertouch message is repurposed for EaganMatrix use to be able to send multiple data sets. So you'll send the ID as the first poly aftertouch data value and the index, the option of that poke, as the second data value. So for example, we will generate a function, we'll call it matrix poke, that'll take two values, a poke ID and a poke index. Those will be the two poly aftertouch 7-bit data values that you'll send in there. The first thing we'll do in the function is we'll send out CC56 with a value of 20 to say, hey, matrix poke's coming, and then we'll send the poly aftertouch data with the values that were sent into the function. So for example, if we want to change our split mode to number 4, internal sound below, all MIDI above, we'll send a value into that of 1, which is the matrix poke ID to change the split, and then we'll send a 4 that tells us what kind of split to change. This basically is doing what our current editor does. Also remember, all the combination splits and combination options have been removed in this new release. They will no longer be supported. Just the standard splits will. So let's take a look now at what other kinds of matrix poke operations might be supported. Quite a few. And in the new EaganMatrix Overlay Developers Guide, I have a full list of all of the pokes and the data associated with them. This will be available once the new firmware is available. We can change with a matrix poke the recirculator programming. We can change MPE priority, mono mode, CVC configuration, rounding modes, recirculator types, the preset loading options, replace, preserve. We can change the new additive buffer. This is the new additive set that you'll be able to import from a sample you create using a new tool that should be available soon. The new firmware is obviously required to support that. You can change your middle C, your transposition. That used to be done with a CC alone. Now you need to use a poke to do that. You can change your wavebank waveform, you can change oscillator filter configurations, you can change SG types, change the delays, you can enable and disable the recirculators. Some of the stuff you can see that's in Midi and global settings you can add to your overlays, and then you can change your Harman sets, you can change the actual type of oscillator or filter you have, change what bank type you're using. But beware, some of the operations I've highlighted in red mean you probably need to reprogram the formula associated with these operations. That will require a heck of a lot more overlay programming because now you're trying to recreate the EaganMatrix itself. Well, you could, as I said, but overlays typically are going to restrict themselves to operations that just change things in the current preset without having to reprogram things internally. That brings us to formula pokes. Formula pokes are when you want to change something that's directly associated with a specific formula. For example, the shape of a shape generator. The shape generator will always be defined in the W part of a formula. In this case, formula D defines shape generator 2, and we want to set that with a pulse option. Let's say it's set now to ramp up. Well, this operates similar to the matrix poke with an addition that's required. There'll be formula poke IDs that tell you what kind of operation to do, just like matrix pokes. And then there'll be your indexes that will tell you the internal value to set for your operation. The first thing you'll do is send CC34 on channel 16 with the formula ID. Each of your now 44 formulas has an ID associated with it. It's just simply the index of that formula, 1 to 44. So formula D will have the formula ID number 4. Then after you send your formula ID, you're going to send your formula poke indicator, CC56, with a value of 19, and then you'll send a poly aftertouch message that will have the poke ID and the poke index. So you'll create your function similar to that, and then if we want to set formula D, shape generator 2, to pulse, I'll send a formula poke with a value of 4, formula D is number 4, value of 50 for the poke ID, that means change your shape generator setting, with a value of 2, which is change to pulse. I don't have to tell it anything about shape generator 2 in this case, because the EaganMatrix knows that formula D is associated with shape generator 2. So that's the basic formula poke. Here are other formula poke options. Again, the full listing of those with all the codes is going to be in the EaganMatrix Overlay Developer's Guide. You can change the X, Y, and Z magnitude, mode, and type of the X, Y, and Z that you're setting. You can change all the ancillary operations, operator precedence, blend select. You can change your shape generator phase. You can change the selection of the shape generator itself, and then of course all of the shapes, and also sample and hold options. So you can see a lot of these formula pokes will involve changing a formula perhaps as well. Some of them might be able to be used at any point. For example, changing the shape generator phase, changing a shape generator shape. That you can probably do without worrying about the formula itself. But if I'm going to change an operator precedence, that could totally change the operation of the formula, maybe to something that totally creates problems for you. But once again, there's no limit to what you can do with your overlay interface. Now, you can also change convolutions. These are typically something you can easily do with your overlay and not worry about reprogramming anything. Anything you can change in the editor now with the convolution settings, you can program that in with convolution pokes. A convolution poke works just like a matrix poke, only we're going to send CC56 on channel 16 with a value of 26 instead of value of 20 to indicate a convolution poke is coming. We'll generate a convolution poke function similar to matrix poke. I'll send in a poke ID and a poke value. The first thing I'll do is I'll send the CC56 with the value of 26 that says convolution poke coming. Then after that, I'll send my poly AT message with my poke ID and poke index. And let's say we want to change the second impulse response to the cloth option. So here then we'll send a convolution poke. We'll send a value of 5, which means select data for the second convolution as my poke ID, and then I'll send a poke index of 12, which is the cloth option. And you can see the new firmware adds about twice as many convolutions now, a lot of new convolutions to experiment with. So finally, we're going to talk about stream pokes. Now, some EaganMatrix operations require to be set with more than just 2 values that you can send with a single poly aftertouch message. So in this case, we're going to have to send a stream, a sequence of poly aftertouch messages to set things. Also, by the way, when I request data from the EaganMatrix module, I will typically get a series of poly aftertouch stream data back that I need to parse and process in some way. Separate video will be on that. So to send a stream, and you can see here all the stream types, a lot of these are really only used by the editor right now, but you may perhaps want to change a graph. Maybe you're using a note graph to add a little Midi sequence to your preset of some sort. Well, to send a stream, what you'll do is you'll send CC56 with the stream ID, one of these values, perhaps 2 being the main graph that you're going to want to change. Then I need to send a set of poly aftertouch messages, a stream of this data, to map to the number of data values that that stream is expecting. In the graph case, that'll be 48 values. Some other streams might request an odd number of values. If you're sending an odd number of data values in a stream, you must always terminate the last poly aftertouch message with a null, with a 0, because that poly aftertouch message always requires 2 data items. Streams always require an even number of data bytes. Then finally, I will send a CC56 with a value of 127 to signal to the EaganMatrix, hey, the stream data is over, process it. as an example, let's reprogram the main graph. So we'll need to send CC56 on channel 16 with a value of 2 because we want to change the main graph, or 3 for offset 1 graph, or 4 for offset 2 graph. Then we'll send our 24 poly aftertouch messages with values of 0 to 96. That's what the graph expects. 24 messages because we need 48 data items in a graph and 2 data items per poly aftertouch message. And then we'll send our CC56 equals 127 stream termination indicator. And that's how streams work. Those are the basic functions that will be used to create your overlays. The only thing we need to discuss in more detail is reading MIDI streams from the EaganMatrix. Let's say you want to read the system presets or the user presets and display them. Let's say you want to read the tags that are associated with your macro controllers and you want to display them. All of this data is available by sending CC109 requests. You'll get the data back that you'll have to have something set up to asynchronously process this data as it comes in and then process it in some way when you get the termination signals for your stream data. So from what I just told you, and with the EaganMatrix Overlay Developer's Guide that will be available soon, you'll be able to program up most everything you need to do for a very sophisticated EaganMatrix Overlay application.